आइए जरा. So it's the carboxylic acid and esters. So in this chapter, we are going to discuss the detail about your carboxylic acid. Okay, like what the carboxylic acid is and what are the properties and what is the difference between the weak acid and a strong acid. How it can be different from those that you have previously studied, that was alcohol, that was alkene, that was alkane. Like what is the difference between the physical property of this carboxylic acid and those that you have studied so far. Okay. Um, First of all, you need to know that carboxylic acid is a weak acid. First of all, carboxylic acid is a weak acid. What is the definition of weak acid? It can partially ionize. Partially ionize means that let's suppose if you have 100 molecules of um, carboxylic acid, okay, if you have 100 molecules of carboxylic acid, so out of 100, only one molecule of carboxylic acid can break down, can ionize, and give you respective ions. Let's suppose if you have this ethanoic acid, so it's going to give you ethanoate and the proton, that is H positive ion. Okay, that's why I'm saying it's a weak acid. That's why I'm saying it's a weak acid. 1% dissociation, 1% ionization. So for a weak acid, the pH is 4, 5, and 6. Okay. When the pH is near to 7, means that this is a weak acid. And when the pH is away 7, like it may be 3, it may be 2, it may be 1, so you can say that this would be your strong acid. Then we have some family members of carboxylic acid that are, you can say, methanoic acid, then ethanoic acid, then propanoic acid, then butanoic acid. Here are some family members. So the suffix for carboxylic acid is oic acid. The suffix for carboxylic acid is oic acid basically. Okay, like methanoic acid, then ethanoic acid, then propanoic acid, then butanoic acid. Like it's methane to methanoic acid. What you are supposed to do, it has only one carbon atom. So I would be writing methane. Then I'm going to remove this E, remove this E and just add oic acid. तो क्या हो जाएगा? Methane and then oic acid. Okay. So methane to methanoic acid and ethane to ethanoic acid, then propane to propanoic acid, and then butane to butanoic acid. So here are some family members. It's following the homologous series as well. If you can count the if you can count the number of atoms and if you can write down the molecular formula, so you will see that it's a homologous series. What is this? It's a homologous series. Let's suppose this is CH2O2. This is C2H4O2. This is C3H6O2. And this is C4H8O2. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I told you the definition of homologous series. I told you that if the difference of the two consecutive group is CH2, like that, so that series is known as homologous series. That series is known as homologous series. Okay. So that's why I was saying that it's also following the homologous series. And then if I talk about the physical properties of carboxylic acid, so remember कि carboxylic acid जो है, it's having a higher boiling point, as compared to alcohol. And alcohols have higher boiling point as compared to alkene and alkane. Because alkene and alkane both contain only London force, or you can say the dispersion force, or you can say the ID force, that is a weak intermolecular force of attraction. There are three types of intermolecular forces of attraction, which we have discussed in chemical bonding. The first one was ID force that can only exist in the non-polar molecules, okay? Which is the weakest force among the intermolecular force. And then the second type of intermolecular force is permanent dipole. Permanent dipole is only exist between the polar molecules, like alcohol is your polar one. How can you identify whether the molecule is polar and whether the molecule is non-polar? It's very easy. If you can see the same elements, so this would be 100% non-polar. And if you can see the different elements, so you can say that this is polar one and it's going to have permanent dipole. But the thing is that we have discussed so many times that hydrocarbons are non-polar. If you are thinking that carbon and hydrogens both are different elements, so why this is non-polar? कि इनकी electronegativity का difference it is not so much. Like you can say there should be a significant difference between the two electronegativities. There should be the significant difference between the two electronegativities. If you are going to see the electronegativities of carbon and hydrogen, so you will see that there is no such difference between these two. So therefore, we say that all hydrocarbons are in the category of nonpolar. And if this is nonpolar, so they are going to have ID force of attraction. Okay. But the thing is, in carboxylic acid, you have two oxygen atoms, as you can see over there. It has two oxygens. Each oxygen is having a lone pair of electron. So it's going to make hydrogen bond. So the third category of intermolecular force is hydrogen bonding. That is the strongest intermolecular force among the intermolecular forces of attraction. So the ID force was the weakest and the hydrogen bond is the strongest one. Okay. So carboxylic acid can make two hydrogen bonds. This is very important. Carboxylic acid can make two hydrogen bonds. और alcohols कितने bond बना रहा था hydrogen bond? Only one hydrogen bond. Why? Because in alcohol you have one oxygen atom and in carboxylic acid you have two oxygen atoms. That's why. That's why carboxylic acid is going to have two hydrogen bonds. So on the basis of this, I can say that it would be having the stronger intermolecular forces of attraction. So more energy would be required to overcome the force of attraction. तो automatically इसका boiling point क्या हो जाएगा? Higher हो जाएगा. That's why. Okay. Or they are soluble in water, just like alcohols. क्योंकि hydrogen bond is going to affect the two things. Number one, the solubility, and number two, melting and boiling point. If there is hydrogen bond, the thing is more soluble, the thing is having higher melting and boiling point. And if there is no hydrogen bonding, the thing is going to be insoluble, or you can say slightly soluble, or it's going to have low melting and boiling point. Lekin. Same goes with this, as I told you in alcohol, as I told you in halogenoalkane, K, as the number of carbon increases, okay, as the number of carbon increases, तो non-polar part जो है ना वो increase होता जा रहा है. As you can see, कि non-polar part is going to increase. So, so if you have increased the significant number of carbons, so it would be coming the dominant factor, dominant factor. So it would dominant and it would affect the solubility. You know, I know that it has a polar part लेकिन जब आपका नॉन पोलर पार्ट बढ़ जाएगा ना, तो that would be responsible for the solubility. So I can say it's going to have insoluble in water. So it completely depends on the number of carbon atoms, or you can say how much long the non-polar part you have. So in the second compound, the non-polar part is higher, and in this compound, the non-polar part is lower. So the first compound is going to have a good solubility as compared to this. Okay. And also, as the number of carbon increases, the melting and boiling point increases. Why? क्योंकि when we were discussing the intermolecular forces, so there are some factors, multiple factors on which the IMF depends. At that time, I told you the first condition is the number of electron and the second one is the surface area. As the number of carbon increases, so the number of electron increases. That's the reason intermolecular force increases. और surface area भी यही होता है कि as the surface area increases, तो intermolecular force increases, or that's why the melting and boiling point will also increase. Okay जी, तो ये important बात है इसमें. Then we have a chemical properties of carboxylic acid. The first chemical property is the reaction of acid with metal. Since this is a weak acid, but this is an acid, we have learned in IGCSE that the acid can react with metal. But this is a special type of acid. This is an organic acid. This is a weak acid. It can only react with the reactive metal. It can only react with the reactive metal. Okay, it's not going to react with copper. It's not going to react with the silver metal. Like KUK itself is a weak acid. So mainly we would be reacting this with sodium and also sometime with magnesium. Okay. Uh, it can also react with alkali. Okay. It can give you an acid-base reaction, right? Okay. Or, alkali is soluble in water. That's the difference between alkali and you can say base. Bases are insoluble and alkali is soluble in water, right? Okay. Acha ji. Hill can also react with the metal carbonate. It can also react with the metal carbonate. It can also react with the metal carbonate, that is sodium carbonate in this case. That is sodium carbonate in this case. What would you observe? You will observe the bubbles of a colorless gas. What is the gas? Carbon dioxide. You will see bubbling, you will see effervescence, you will see fizzing. Bubbles of colorless gas means that if you can observe the gas, so this is an indication for the successful reaction. That's the reason in the product side, the carbon dioxide gas is released. Since this is the weak acid, but it can not react with the less reactive metal, but can react with reactive metal. So we need to show the particular reaction in which it's going to show its chemical behavior. Okay. So nothing, no temperature is required, no pressure is required, nothing, no catalyst is required. Only at the room temperature they would be reacting with each other. Okay. आप देखो ना सोडियम तो it can react with water as well. So they तो फिर भी acid है. It can give you a vigorous reaction, explosive reaction. क्योंकि वाटर के साथ उसका इतना वो रिएक्शन होता है तो अल्टीमेटली इफ यू हैव दिस कार्बोक्सिलिक एसिड सो नाउ यू कैन थिंक. Okay, you can imagine. Then after discussing the chemical properties of carboxylic acid, it can react with the reactive metal, it can react with an alkali, it can react with metal carbonate. It doesn't mean that we can react any metal carbonate with this. I told you that it's a weak acid, so it needs some particular reagents. तो ऐसा नहीं है कि we are going to have any unreactive metal or unreactive thing, so फिर ये reaction नहीं करेगा. तो इसलिए I'm taking like the group 1 metals since they are the more reactive metals, right? Then we have formation of carboxylic acid, like the preparation of carboxylic acid. Okay. So I'm going to prepare it from primary alcohol. I'm going to prepare it from primary alcohol. Okay. We can oxidize our primary alcohol into carboxylic acid. So we need an oxidizing agent. We need an oxidizing agent. There are main two types of oxidizing agent. Number one, KMNO4, like potassium manganate. Number two, number two, potassium dichromate. Potassium dichromate. Okay, K2Cr2O7. Not only this, for oxidation, we generally add few drops of acid, which can be used as a catalyst. ये जो acid तुम डालते हो ना, they are going to act as a catalyst. Okay. So what you would observe if you are going to oxidize your primary alcohol into carboxylic acid by using K2Cr2O7, you know the color of K2Cr2O7 is orange initially, pure. When you have K2Cr2O7, it's orange. It's orange. Or after oxidizing your primary alcohol into carboxylic acid, it would be turning into green. It would be turning into green. So orange to green is your observation. If you have observed orange to green means that your primary alcohol has changed into carboxylic acid in the presence of K2Cr2O7. But if you are taking other oxidizing agent, that is KMNO4, so the initial color for KMNO4 is purple. After oxidizing your primary alcohol into carboxylic acid, you will observe purple to colorless. You will observe purple to colorless. In both of the reactions, you are going to provide heat. Heat under reflux. You know, heat under reflux means that you are supposed to provide heat to the reactant, that is your alcohol, which is highly volatile in nature. It can escape. It can escape from the beaker. It can escape from the round bottom flask. It can escape from the container in which you can have this alcohol. To avoid this, I'm supposed to heat in such a way that I can heat it properly without the loss of your alcohol. So that's why we are saying that we are going to heat it under reflux. Okay. Or this is the first way to prepare carboxylic acid. The another way to prepare carboxylic acid is to oxidize from aldehyde, like is to oxidize your aldehyde. So primary alcohol can be oxidized into carboxylic acid, and aldehyde can also oxidize into carboxylic acid. Okay. You can use the same oxidizing agent. Okay. You can also use the Fehling solution as well. You know, Fehling solution is also an oxidizing agent. Fehling solution is also an oxidizing agent. You can also use this. You can also use the tolerance reagent. You can also use the you know, that's one of the reason that we used to say that they can only react with aldehyde. They are not going to react with ketone. So that's the good difference test between aldehyde and ketone. If the reaction is successful, means that your aldehyde, you had aldehyde, because it's not going to react with the ketone. Ketone cannot be oxidized. We have discussed in carbonyl compounds. Ketone further oxidized नहीं होता है. So that's why Fehling solution cannot do anything. Tollens reagent cannot do anything. So right now we are going to discuss how can we prepare carboxylic acid in different ways. So we can oxidize our aldehyde into carboxylic acid by using different oxidizing agents. So I told you the first one, that was K2Cr2O7, potassium dichromate, in the presence of few drops of acid that can be used as a catalyst. And then we have the different oxidizing agent, that is KMNO4. Then we can also use Fehling solution, and then we can also use Tollens reagent. Okay, ये सारे के सारे क्या हैं? Oxidizing agents हैं. Okay, but I know Fehling and Tollens, they both are weak oxidizing agents, but you can oxidize if you're going to provide some sort of heat. So without heat, the reaction is not possible. Okay. क्योंकि this is a weak acid, it requires some sort of external energy, you can say. Set. Okay. Uh, और और आइए जरा. Then we have formation of acyl chloride. Then we have formation of acyl chloride. What does it mean, formation of acyl chloride? So see this. Formation formation of acyl chloride. Formation of acyl chloride. This is also known as derivative of carboxylic acid. Okay. तो भाई मेरे पास है एथानोइक एसिड. एथानोइक एसिड जो कि ये है. I am going to react with PCl5, phosphorus pentachloride, at room temperature and pressure. You know what should be the product? Okay, this is going to be produced, which is ethanol chloride, acyl chloride, and the rest of the inorganic products are the following. What you would observe, due to the presence of HCl, we will see steamy fumes. We will see steamy fumes. Okay, this is your observation, and this is ethanol chloride. It's a derivative of carboxylic acid. We can also use PCl3 as a reagent rather than PCl5. Same product. Okay, that would be your inorganic product. Or दूसरा, you can also react with thionyl chloride. You can also react with thionyl chloride just like that. thionyl chloride. और ये बनेगा सेम प्रोडक्ट और बनेगी एक्स्ट्रा प्रोडक्ट दैट वुड बी SO2 and HCl. Again, you are getting HCl. So, HCl ka you will see steamy fumes. HCl ka you will see steamy fumes. So, if you can see steamy fumes, so means that this is confirmed. Like the presence of OH group is confirmed. So that's why the PCl5 or a PCl3 or SOCl2 has reacted with the chlorine wala part. That's the main theme of this chapter. Okay. So this is also one of the chemical properties of carboxylic acid. सही है. अच्छा जी. Then
This is also one of the preparation of carboxylic acid. I told you okay, we can oxidize alcohol, we can oxidize aldehyde. We can also hydrolyze nitrile compound. नाइट्राइल बोले तो CN, नाइट्राइल बोले तो CN. तो आप इसकी हाइड्रोलिसिस करवा दो, अगेन यू विल बी गेटिंग कार्बोक्सिलिक एसिड. ओके, आप इसकी हाइड्रोलिसिस करवा दो, अगेन यू विल बी गेटिंग योर कार्बोक्सिलिक एसिड. There are two types of hydrolysis of this nitrile: acidic hydrolysis or alkaline hydrolysis. Just like an ester, if you remember from IGCSE that we used to discuss first the preparation of ester, then the hydrolysis of ester. So we can hydrolyze this nitrile compound by the reaction of acid, HCl, aqueous, and heat under reflux. So when you would be adding few drops of HCl and just you started to provide heat under reflux, so then you will be getting your carboxylic acid. Okay, then you will be getting your carboxylic acid. Now you can see that the number of carbon atoms have been increased. In the reactant side, I had 3 carbon atoms. In the product side, I have 4 carbon atoms. So nitrile is used to increase the number of carbon atoms. We'll see in the questions. But if you are going to have alkaline hydrolysis, okay, you're not going to add acid, but you're going to add alkali, that is sodium hydroxide in this case. So you will be getting this. Acha, you know, this is the salt. This is the salt basically. क्योंकि यहाँ sodium आके लग गया. But remember, the first of all, you made this, that is carboxylic acid. As you know that you have added NaOH, like alkali. So obvious सी बात है, NaOH would be taking the proton of this carboxylic acid and would be producing the salt. So this is also one of the preparation of carboxylic acid. This is also the one of the preparation for the carboxylic acid. Okay. So that's all for carboxylic acid. Okay. And then the topic, that is your ester. We can form an ester. We can form an ester uh, by the reaction of alcohol with carboxylic acid. We can form an ester. As this process is known as esterification. This process is known as esterification. In this process, we say that we can prepare ester by the reaction of alcohol with carboxylic acid. See this? In esterification, it's a formation of ester. Hmm, okay. Or ester and water. Ester and water. Okay. This is reversible reaction. This is reversible reaction. Okay. To make an ester, we need a catalyst, that is concentrated sulfuric acid. Okay. And then we are supposed to provide some sort of heat. Then we will see that we got an ester. Okay. So I'm taking the simple carboxylic acid, which is ethanoic acid, or this is ethanol. Hmm. So
Alcohol can give its hydrogen and carboxylic acid can give its OH. Alcohol can give its hydrogen and carboxylic acid can give its OH, and they would be forming an ester. They would be forming an ester. Okay, just like that. It's very simple. Here, the sulfuric acid is used as a catalyst, concentrated, and the reaction is reversible. The ester can change into the reactant as well. Okay, this is known as hydrolysis. If you are going forward, this is called esterification, and if you are going backward, this is called hydrolysis. Remember, if you are going forward, it's an esterification. If you're going backward, this is called hydrolysis of an ester. Okay, so we can hydrolyze an ester. Hydrolysis of ester. Again, I would say that we have two types of hydrolysis, just like a nitrile, acidic and basic. I'm going to take this ester again over there. Let's suppose this is the test. Water से reaction करवा रहा हूँ. It would be breaking down just like that. I would be getting this. You got your carboxylic acid and alcohol again. ये है hydrolysis. To get your reactants again, you are supposed to do hydrolysis of an ester. In this hydrolysis, I have used acid as a catalyst. That's why I'm getting this product. What if, what if I'm going to do basic hydrolysis? What if I'm going to do basic hydrolysis? I'm not adding the H2SO4 in this. I'm going to add alkali. So, rather than the carboxylic acid, the salt would be formed. The salt would be formed. The salt of carboxylic acid would be formed. The salt of carboxylic acid would be formed. So this is the hydrolysis of an ester. That's all about this chapter. That was carboxylic acid and esters. Then inshallah we will be doing the past papers. Okay.